Okay. Good morning, dear students. After doing the relation, after doing the ordered pair Cartesian product of two sets, we are coming to the main topic, that is functions. This word will be mostly used in the mathematics whenever you come across with the chapters like trigonometry, differentiation, and integration and calculus chapters. So this word function is very important to understand. So first of all, let me just clear you one thing. Function is a special case of relation. How? Till now we were understanding the meaning of relations, which says that, say for example, if you have set two non-empty set, then we were saying A is related to B with such and such statement. A is related to B by this and this thing. We wrote, no, A is less than B, if I'm saying. So here is less than is called the relation. Now how does it convert into functions? So let me just clear you those 2 or 3 conditions, that how relation converts into function. So you need to clear that point first. Then we will come to the definition, and then we will come to the more deep into it. Alright. So let me just clear those 2 or 3 conditions, which is or rule which is necessary for a relation to convert into function. Okay. One thing, every function is a relation, but every relation is not necessarily a function. I will explain you how. Okay. So here are the 3 rules which will clear the thing that how relation changes into function, and what all important points you need to keep in your mind. Okay, so how relation changes into function, the very first I'm explaining you, this is the A set and this is the B set, which we have seen in the relations in the arrow diagram. I'm taking 4 elements in this domain. This is called full, this is what, this is, we consider that as domain, and this is range. Okay, now A is related to D, B is related to E, C is related to F. Now this D is left behind. So this relation cannot be a function. This is the first rule which you have to keep in mind. Okay, this relation cannot be converted into function. This is the very first rule, because one is left behind. It has no image in set B. Alright, so what the function with this, what can we understand? A definition of function, that every element in set A must have a image in B, then only it is considered as a function. Keep in mind. Alright, now come to the second. In this I have explained you that in this the relation cannot be the function. Now come to the second point. A has 2 images, D and E, and B is here, B is related to G and C is related to F. This also here, this is not, that means this relation cannot be a function. Why? Because one element, we are getting the 2 images. Okay, so one object can never have the 2 images. So similarly in the function, you have to understand that the elements in the domain have one image, one and only one image on B. So this cannot be a function. Now here the relation can be the function. Why? Because 2 objects can have one image. Okay, this can be possible, that the 2 elements in this set can have 2 images, but one element cannot have 2 images. 2 elements can have a common image, and as C is related to E, D is related to F, so this relation can be converted into function. I hope you have understood these 3 rules, and on the basis of these 3 rules we will be understanding the definition of the function. So with that it would be very clear. All right, so I'm reading the definition that a function from x to y is a rule which associated to the elements of x a unique element of y. Have you understood? Or let me just say it in terms of a and b, that in other words the function from a to b is rule which associated to each element of a and has a unique element, yeah, a unique image in y. All right, so I hope with this rules you have somewhat have a understanding of function, that what does the function actually means. Okay, now let me make one diagram. Okay, so this diagram will clearly depicts the actual meaning of a function. You consider this as a machine. In this you are giving an input value of x. It went inside, and has it did some function. Let us consider that as f, and with respect to, we got the output in terms of y. Say for example, I'm writing y is equal to fx. This is the very general way of writing. And what do we say? Y is a function of x. है ना? Because y is a function of x. Now this function can be anything. Like say for example, I'm writing y is equal to sine x. So this function. Here it will be a trigonometric function. So you give the value of x inside. Your function is sine function. So you will get answer. Say for example, I'm giving the value 30 degree. So this 30 degree went inside, and sin 30 it did it, मतलब इसने अपना function का काम करा, sin 30 degree की value निकाली. What is sin 30 degree? 1 upon 2. So your y is equal to 1 upon 2. We got the output as 1 upon 2. So like this, just try to make it. Say for example, I'm writing y is equal to log x. So y is a logarithmic function of x. You just put x is equal to 10. Log 10 is what? 1. So now it worked as a logarithmic function. We will be seeing there are so many functions: logarithmic function, trigonometric function, modulus function, you have exponential function, algebraic function, polynomial equations, and inverse trigonometric functions. Many functions are there, and they see, understand the meaning of function in like locally. You understand in function, we if we see the dictionary meaning, function means there is some specific work. Okay, it has some specific responsibilities, it has some specific function of it. All right, in mathematics also there are many of the functions, and how those functions are framed by the relations only. That means they have some certain relations, and they are converted into function with those three rules I've explained you in the prior. All right, so I hope all my efforts for explaining you the meaning of function should come up. Okay, now I will be explaining you what are the types of function. Before that, it is given the main features of a function. Those 5 features, just read it. They are very important. Just write it in the fair copy too. Okay, let's get started with the types of function now. So very first function, which says that one function. This is also called injective function. So I'm trying to explain you with the examples. We just grasp the things if we are explained with the examples. So I try to explain the things with the example, and then we go to the definition, so it becomes more clear to us. So one function, it is also called injective function. Now with the diagram, as you can see that I have for each element in x there is one image, one and only one image in y. So a is related to e, b is related to d, and c is related to f. So this is called one function. Every element has a image on b. Okay, every element of A has image on B. This is called the 1 1 function. All right, onto function, this is called surjective function. What does this say? Actually, it is the opposite of 1 1 function. How? Every image must have a element in the X. As we say, every element has one image, so every image must have one element in it. Okay, this will call a onto function. So like a function from A to B is called onto if each element of Y has image on at least one element on X. All right, so this will called a onto function. Okay, many one function, that means the two elements are having a one image in Y, they two are also having one image on V, and this is related to this one. So this is called many one function. Okay, that multiple elements are having a single image, that is called many one function. All right, let us understand two more function, that is into function and one one correspondence. Okay, let us finish these two functions also. Another comes the into function. Now from the diagram, can you understand that I have made a relation of A to E, B to D, C to F. Now one image is left. Alright. So this is called the into function, that not every, that means at least one image has no element, has no, like there is no element of this image, at least one. So that is called into function. And one word correspondence is, it is called bijective function. Actually it is a mixture of injective and surjective, that means one one and onto. One one and onto, if you just mix it, you will get one one correspondence. Each element is having each image and each image is having each element, so it combinedly called the bijective function or one one correspondence. So that's it, we understood the types of function. Now let us take the questions and understand. All right, regarding the questions, just wait, you do in the book, you do up to question number 10th. Okay, because up to 10th, what all things they have asked, regarding that, is this is relations as functions or not. You will be given one question, you need to detect that this relation can be function or not. I've explained you those three rules. Okay, just go through book also one time, just read the theory what is given in the book, write the definition of function, make that means that diagram which I have made. Secondly, write the rules which I have explained, and types of function, definition of each and every function. Okay, and the examples, write it and do up to this 10th question. Okay, some questions are like objective type or like orally, which can be done in the book, that you can do and see the examples. Let me tell you, just to see the examples up to question number fifth or sixth, you can see, no problem. All right, so just do these questions. In the next video, I'll explain you the questions of this, how to solve the question and how to prove or show that whether a function is one one function or onto function and so on. All right, thank you so much, have a nice day, do practice, bye bye, take care.